Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, we're going to talk about the future of the space program, or what's left of it. Some people say that NASA is an agency to nowhere. It has an identity crisis. Which way to go? Should we go to the moon? Should we go to Mars? Should we go to asteroids? It's not entirely clear. So we're going to bring on two special guests today. The first special guest is an astronaut, Tom Jones, who'll talk to us about the good old days before the space shuttle was canceled. The good old days when we sent astronauts into outer space on a regular basis. Now, of course, we pretty much piggyback on the Russian space program, launching our astronauts from the Soyuz space capsule in Kazakhstan. And, of course, President Barack Obama has put his eggs in the egg of commercial development, hoping that private enterprise will pick up where the government no longer goes in terms of putting astronauts in outer space. And then our second special guest says, nonsense. Why bother with the moon at all? Let's go on to Mars. We're going to bring on Robert Zubrin, founder of the Mars Society, and one of the leading advocates of basically bypassing the moon and going on to the red planet. Well, back during the days of President George W. Bush, it seemed so simple. We would have a replacement for the space shuttle called the Constellation. We would then go on to the moon, and perhaps maybe after that on to Mars. Well, certain things hit. Among them, the economic crisis, the coming in of President Barack Obama. The space shuttle program was canceled. The mission to the moon was canceled. And so now NASA could be suffering from identity crisis. Which way to go? Should we go back to the moon? Some people say, no, let the Chinese, let the Indians, let the Japanese and the Europeans go to the moon because they've never colonized the moon with their astronauts, so let them do it. What we should do is go on to the asteroids and maybe even beyond that to Mars. In fact, some Google billionaires have stated that we should make it a commercial operation to mine the asteroid belt. Well, who knows for sure? My personal attitude is, well, if Google billionaires are willing to pay the bill rather than the taxpayer, more power to them. Let someone else pay for the mining of the asteroids. Maybe there are trillions in riches to be found in the asteroids. But meanwhile, Robert Zubrin of the Mars Society says all of this discussion is nonsense because what we really have to do is bypass all of this and go on to the red planet. That is our destiny. Well, who knows for sure? Anyway, let's begin with today's program. We're going to be talking about the exploration of outer space. The Indians and the Chinese have made it a priority to go to the moon. And we have two special guests pre-recorded. The first is Tom Jones, NASA astronaut, who will talk to us about what is it like to be out there in outer space. And by 2020, our astronauts should be walking on the surface of the moon once again. And in fact, we may even have a traffic jam around the moon. The Chinese may actually beat the United States to putting men back on the moon by 2020. And not to be outdone, the Indians want to send unmanned probes to the moon, leading perhaps to their astronauts also going to the moon sometime perhaps after 2020. Not to mention the fact that the Japanese and the Europeans also want to get in the mix. So definitely, we might have a traffic jam on the moon around 2020. And then in the second half of Exploration, we're going to bring on a pre-recorded interview with Robert Zubrin. He is perhaps the most vocal proponent to put men on Mars. He's the founder of the Mars Society, former aerospace engineer. So we'll talk about the pros and cons of going beyond the moon onto Mars. So once again, our first special guest is astronaut Tom Jones from NASA. The first question for you, Dr. Jones, is, as a youth, how did you first get interested in exploration and the space program?
It's easy to remember for me. My grandmother was a big reader, and so she went down to the five and dime store and bought on the remnant table a book called Spaceflight, The Coming Exploration of the Universe. It was one of the little golden books of knowledge that you could get back in the 1960s. And so I was 5, and she gave me this book, and it was filled with wonderful illustrations, paintings of what space flight might be like. There were no photos because no one had gone into space yet, but that really captured my imagination. These astronauts and spaceships were fascinating subjects to me, so I began to read more about those on trips to the library, and very quickly got fascinated with the subject of space science and astronomy. When I was 12, my parents got our family our first telescope, and I became the sole operator of it. It was tough to get other people to let other people use it, but I had it out a lot in suburban Baltimore. And along with the fact that they were building rockets in my hometown as part of the Gemini program in the middle 60s, I think all of these things combined to make astronautics and astronomy a very favorite subject of mine, which I just devoured in school and at the library.
And you went to the United States Air Force Academy. Why'd you go there, and did you have in the back of your mind this career path that would take you into outer space?
Well, certainly by the age of 10, I was aware of the job of astronaut and the fact that it was a reality and that they were building rockets in my hometown. And I said, well, I'd like to ride a machine like that someday. And during the Apollo program, as we watched the first run-ups to the moon landings, I was aware that test pilots were the ones who were selected to be astronauts. So if I wanted to do the job, I certainly had to become a test pilot. And you've got to go through a military flight training program. And I chose the Air Force. So the Air Force Academy seemed to me the best place that was focused on flying in the country. And that's why I tried to enroll there. By the time I was in college, the moon landings were just finishing. And so it was very clear that I still wanted to do this, and I thought that was a great jump on the program, getting into flight school, becoming an Air Force pilot, and then becoming a test pilot.
And I understand that you flew missions on B-52 bombers for the Strategic Air Command. Could you elaborate?
Well, after a year of pilot training after graduation, I got a basic science degree at the Air Force Academy. I knew I was going to be flying for a while and then try to get into test pilot school. So my first assignment after pilot training was to go to Strategic Air Command, which was an outfit that was involved in nuclear deterrence. And my mission as a B-52 crew member, a co-pilot, and then an aircraft commander was to sit alert duty out at the base. About once every 3 weeks, I would live for an entire week out at the base, trying to make sure that the Russians would always fear a counterattack if they tried to do a surprise attack on the U.S. So we trained for the nuclear delivery mission, a doomsday mission. And it was quite a strange existence. Every third week, you'd be waiting for the horn to blow, signaling a Russian attack, and then you'd jump into your planes and taxi out as fast as you could and take off. That's what we trained for. And fortunately, nobody ever shot at me, and the Cold War wound down to its eventual conclusion. While I was doing that, though, NASA brought along the space shuttle and changed the rules on how you could become an astronaut.
Now, many people who watched the movie, Top Gun with Tom Cruise, have dreamed about dogfights out there in the wild blue yonder. However, you went for a PhD in planetary sciences. So how did that come about?
Well, to tell you the truth, I was in the Air Force and sitting alert duty, and I remember clearly being out there on the base during one of those weeks of duty and watching the miniseries Cosmos by Carl Sagan. And this was a man and a television production that really captured my imagination. And I said, here's a guy who's doing this for a career, the thing that I've loved to study and read about all these years. And now that NASA is looking for scientists and engineers, maybe I can become a space scientist, and maybe that would be an alternate path. I knew that test piloting would be a tough assignment to get. It was very competitive in the Air Force, and especially for bomber pilots who weren't widely needed at that time. So after watching Cosmos and reading some more books about that particular profession, I decided I'd go back to graduate school and see if I could become a practicing research scientist.
Now, a lot of people ask the question, if I want to become an astronaut, what do I do? Do I send a postcard to NASA saying, sign me up? What is the career path? What is the process by which somebody out there can realize a dream of going into outer space?
Well, it's easier today with the Internet. You can get on the Internet and read all about astronaut selection at nasa.gov, nasa.gov, their website, and search for astronaut selection. But back then, you just wrote a letter to the Johnson Space Center in Houston where the astronauts train, and I got a reply back from the selection office, and they informed me about the basic qualifications. You have to send in an application, which includes a big civil service exam and a lot of paperwork to fill out, as well as a medical exam. And you just send in that application, they keep it on file, and then every time that they select a new group of astronauts, they'll notify you to see whether you're still interested in applying. And so I started that process in 1986.
Now, 1986 was also a watershed year because that's when the Space Shuttle Challenger blew up on international television, a very sobering event. 7 astronauts tragically lost their lives in that accident. And we sometimes forget that going into outer space is not a Sunday picnic, that about 1% of the time there is booster rocket failure and major malfunction of rockets. So was that sobering? How did that impact on you?
Oh, it was terrible. I was watching that accident. I was watching with the launch of that mission with Krista McAuliffe, the first school teacher to go into space, with a bunch of school students, elementary school students at the University of Arizona, where I was a graduate student. And the catastrophe unfolded before us on this big screen TV. And, you had to try to make some sense of it for the kids and tell the kids that there was no hope that they'd gotten out. And it was a terrible emotional blow. Next door at the Lunar and Planetary Lab where I was studying, everyone was completely floored, devastated by this emotionally, even though most of the people were involved in planetary science and astronomy and robotic missions. They knew how serious this was for the future of space travel and exploration in general. So it was a real body blow. I had met the commander of that mission about a year before, and he'd encouraged me to apply to become an astronaut. He was a very motivated guy who was clear about his mission, and it was infectious. It motivated me to follow in his footsteps. And after his death, Dick Scobie, I decided that, he must have really believed in this to risk his life in such a way. And I knew that my desire to do it was very strong, and I thought if people like that I look up to are willing to risk their lives, then I still think I could find the courage to do the same thing. And I talked it over with my wife before I began applying.
Now, you're a former test pilot, and you know when you go into that cockpit that you're putting your life on the line. You know that unlike a civilian, which wants lots of life insurance and assurances there's no problem, you know you're putting your life on the line when you go into a jet airplane. Now, when you become an astronaut, are the astronauts also told the same thing? We have civilians going into outer space. We have politicians and multimillionaires now going into outer space. Are they really mentally prepared for the fact that, like I mentioned, roughly 1% of the time there is catastrophic failure?
Well, we're certainly aware of the risks. As a pilot, I didn't become a test pilot. I actually left the Air Force after just flying bombers because I wanted to pursue this science path. But I knew that the professionals involved in flying the shuttle were aware of the risks. Of course, Scobie certainly was. And I decided that there must be a recognition among all the crew members that what they're doing must register on them as being so worthwhile that they're willing to risk their physical safety, even their lives, to accomplish these missions. And when I got into the astronaut corps in 1990, I found that to be true, that people were thinking of this as a long-term program of exploration. They figured that the benefits they'd bring back from each mission would be building blocks that future explorers would use to return to the moon, get to the asteroids and Mars. So we all viewed this as a continuum, and each little contribution that we made was worth the risk of our lives. Now, the shuttle's a pretty safe machine, even though it's had 2 terrible accidents. It's one of the most reliable rockets that's out there. So you can always tell yourself that it's not going to happen to you, but you must recognize that it's a finite possibility that each mission's got 1 in a couple of hundred chances of leading to a catastrophe.
Okay, now let's get into the guts of your book. That is the training of an astronaut and what it's like there to orbit the Earth and look down from outer space. First of all, the training. Let's talk about going into swimming pools, going into 1,000 horsepower centrifuges, going into the Vomit Comet. What is the grueling regimen that astronaut training entails?
Well, to begin with, it's much like a college curriculum of investigating the basics of spaceflight. So you bring in all these people who are test pilots and scientists and engineers, and they have varied backgrounds, but everyone's capable of learning. And so essentially it's a graduate course in spaceflight and its fundamentals and the systems that allow us to survive and work up there, the space shuttle in this case. So it's a year of astronaut basic training. And you start in the classroom, read a lot of books, get a lot of lectures. So that's very familiar to most of us. And yet it moves very quickly into simulator training, where you're actually flipping switches, reading checklists, working as a team to put into practice what you've learned in the classroom. And there are also a lot of ancillary training experiences that are quite fun, even though they're very serious in mind, like survival training. What do you do if you bail out of a jet or out of a shuttle and you come down in some distant location where you've got to await rescue. So we had water and land survival training. We also, as you say, rode the centrifuge to prepare us for the accelerations of launch, scuba training to prepare us for underwater training in a spacesuit to simulate free fall, and finally that ride on the Vomit Comet that everybody looks forward to, where you get 20-second doses of free fall as the airplane rides this roller coaster path through the sky. And that's both exuberant and exhilarating, and then finally in the end it's an endurance contest to see if you can keep your stomach and your mind together while this airplane does these gyrations. But it's great to experience free fall.
Now, people who saw the movie Apollo 13 saw Tom Hanks floating for what seemed like forever, and people said, well, how'd they do that? There's no room for wires in that tiny little capsule. How'd they get Tom Hanks to float like that? And as you mentioned, it was this airplane called the Vomit Comet, and there's a reason for that. People throw up. Is that right?
Well, some do. Most people get a little queasy after the end of an hour and a half on that plane, where you do 40 up and down roller coaster cycles to give you those cycles of weightlessness that last 20 or 25 seconds. It's very aggravating to be in free fall for 25 seconds and then be slammed to the floor with 2 times the force of gravity as you pull out. And when you do that over and over, it tends to tumble your gyros and lead to nausea. I found that I never really got aggressively sick up there, but I certainly felt after the end of those 40 parabolas that I was ready to walk wobbly off the airplane and go sit down quietly for a while.
And let's talk about weightlessness. Weightlessness is the state of free fall. That is, if you're in an elevator and someone cuts the wire of the elevator, God forbid, you are in free fall and you are weightless because the floor of the elevator falls at the same rate that you do, giving you the illusion that there's no gravity. Of course, there's gravity. It's pulling you to the floor, but the floor is falling at the same rate as you. Same thing with the Vomit Comet. You're essentially being hurled like a rock into the atmosphere, and you are in free fall. So the question is, if you're in free fall, that sensation is a sensation of dying. That is, you're falling off a skyscraper. So is that the sensation that you have, that you're thrown like a rock into the atmosphere in the Vomit Comet? Is a sensation like the sensation that you're dying?
Well, fortunately, your body is pretty easily fooled. Your mind is fooled because you're in a cabin of an aircraft or you're in the cabin of a space shuttle, and you can't tell that you're being hurtled through the atmosphere or around the planet at hundreds or thousands of miles per hour as you fall, either on this roller coaster parabola or in an orbit around the Earth. So to you, your surroundings are falling with you. They all appear motionless. That's your frame of reference. And so you just appear to be floating. And so it's rather a gentle feeling. You don't feel any motion of high speed or even standing on the edge of a precipice and leaping off. So it's pretty easy to get used to. It's just a gentle lifting or a floating feeling, and it's nice to be able to move with just a fingertip push against the walls. And I find it's something that you actually forget about after a couple of days.
Now, you spent 52 days in Earth orbit during the 11 years you were in the astronaut program. So everyone wants to know, if you're up there for not just 20 seconds, but for days on end, how do you do very simple bodily functions? Like, for example, eating. How do you eat when your food floats in front of you? How do you drink if water will simply float to the ceiling? And what the question everyone wants to know is, how do you go to the bathroom?
Well, all of those subjects I try to explore in skywalking to give you that personal experience of being in there. The eating, fortunately, is almost a non-issue. All of your swallowing and digestive functions seem to work just fine with the peristalsis that moves things through your digestive tract at work. It doesn't need gravity to function. You do have to eat these foods out of a pouch and drink liquids from a pouch with a straw inserted so that food and debris and globules of liquid don't float around the cabin and mess up the systems up there. So it's rather tedious after a while that you have to eat one package at a time. You don't get to sample 3 or 4 dishes at once. You've got to eat in a serial fashion, and it almost becomes perfunctory after a week of the novelty wearing off. So, but it's aside from a little bit of extra time and care required, it's actually quite easy to eat and drink. And I still enjoyed the varied menu that we had available to us, even though the foods aren't fresh. They're at least freeze-dried or irradiated or thermostabilized, so they retain some good flavors. Now, the bathroom question, down here on the ground, gravity makes everything go where it's supposed to. And as I write in the pages of Skywalking up there, you've got some special training to use because we use air instead of gravity to make things go where they're supposed to. Liquid down a suction hose where each crew member uses a personal funnel to guide the liquid into the tube. And for solid waste, it's blown into a storage tank underneath the commode seat. And then the clever thing about it is that the solid waste tank, while it's not in use, is exposed to a vacuum. So the solid waste is sterilized and dehydrated, so the next time it's used, there's no odor or chance of a pathogen getting back into the cabin. It's quite clever. And while it takes longer to use the system than on Earth, it actually functions quite well.
Well, according to the book The Right Stuff by Tom Wolfe, when our first astronaut, Alan Shepard, was sent into a suborbital trajectory, he had to go to the bathroom. He told Mission Control he had to go to the bathroom, and Mission Control vetoed it. And so they sent him into outer space, where he essentially urinated in outer space. Now, that is not a good thing to do, right? Because if you have liquid inside your spacesuit and you are weightless, it could be a mess, right?
Well, it certainly was a mess, and I'm sure he was quite a smelly guy when he came back and got out of the suit. But he survived just fine, and that's because of spacesuit design. They don't put any electronics generally inside an oxygen-filled suit unless there be an ignition source that could lead to a fire. So the inside of a spacesuit tends to be a quite benign place, and the liquid was just a little bit of mess. Fortunately, on the space shuttle, we deal with free fall inside a spacesuit by using diapers, large, absorbent, adult-sized diapers that can take care of that eventuality. And, the space shuttle itself, provides a means to get out of the suit right after you arrive in orbit, and you don't have to put the suit back on until re-entry. So then you can use the bathroom facilities that we just discussed. So we're a long way from the right stuff now, and people seem to be able to deal with this quite easily.
Okay, now what is it like spiritually and emotionally to be in orbit, to look down on the planet Earth as you are in a spacewalk, suspended, orbiting the Earth, suspended in mid-flight with this little cable that connects you to the mother craft? What is it like to look back at the Earth?
Well, Michio, this was a great experience. I had been dreaming about spaceflight since I was 10, and here I was 39 years old on my first mission, and as I write in Skywalking, I got to orbit. I was so busy with my initial jobs that it was about an hour before I actually had a moment to look out the window. And I'll never forget that first impression of the Earth. I was looking out on the night side of Earth, and instead of stars, I saw this big round space or gap where stars should have been. That was the dark side of our planet. But on the very edge, the limb of the Earth, was a gentle band of robin's egg blue light that was growing in intensity and widening along the horizon of the Earth, and that was the coming sunrise. And this beautiful, delicate blue, and the fact that I was finally looking back at my planet after waiting for almost 3 decades to get there, brought tears to my eyes with the realization that I had finally arrived at that moment in time and space. And, they were tears of gratitude to God for sending me up there and giving me the chance to do this, and they were just tears of appreciation at the beauty that I was seeing. And throughout my experiences in space on the other 3 missions I flew, the view of the Earth never became boring, or I never became blasé about it. It was always riveting. I had to tear myself away from the windows to go to work because it's always such a lovely sight and so attractive to a human being to gaze on our own world.
And do you also get a sense of the fragility of life? First of all, the atmosphere is extremely thin, and yet it's like the skin of an apple, and yet it creates life on the planet Earth. Not to mention the fact that the Earth is suspended in this rather hostile environment of cosmic rays and potential meteor impacts. So do you get a feeling of the fragility of humanity that we are, quote unquote, on spaceship Earth?
You certainly get a sense that the Earth is a varied and delicate place. You see immense variety in color and in texture as you travel around the planet once every 90 minutes. Looking at the Earth's horizon, you can see this thin blanket of the atmosphere. You can look down at night and watch meteors burning up in it below you, and you can see the air glow layer high in the atmosphere against the dark night full of stars. So it's aesthetically beautiful, and you're aware of how thin that envelope of air is in particular. I found that you wanted to get to these thousands of places on Earth that you could see, that the rainforest, the glaciers, the high mountain peaks, the river valleys. You wanted to go personally to all of these places to learn more about the planet, and yet you realize as a human being you're never going to live long enough to go to all of these places that you've seen from orbit. I felt a great attraction and sense of longing in my heart to be part of Earth, and I felt separated from it to some extent, especially thinking that I was half a world away from my family most of the time. But generally, I had this great attraction for this lovely planet of ours, and I can't imagine what the Apollo astronauts must have experienced traveling 1,000 miles farther away in space than I did. And it was so strong for me, I'm sure that they must have had a great longing to get back.
Okay, now let's talk about the downside of being in outer space. For example, the Russians set the world's record for being in outer space on one mission, being lofted into space for over a year. And when that cosmonaut came back down to Earth, he could barely crawl. He was almost like a worm. The atrophy of the muscles was so great that he could not stand up. And so let's talk about the fact that when you're in space, you have enormous muscle and bone loss.
Short-term space flight doesn't present many problems. We exercised every couple of days while we were in space. The longest trip I had was 18 days. And so if you do a medium amount of exercise for an hour every other day, you're going to keep your heart, lungs, and muscles in good enough shape to do any physical task that's required and also to withstand re-entry. And then you can sort of stagger off the space shuttle and get your land legs under you just as you were coming back from a long sea voyage. And within about a half an hour, you can walk under your own steam with no great worries. You feel heavy at first when you come back to Earth. That passes in about an hour. The longest effect that I felt was about 3 days of lacking a fine sense of motor balance. So I couldn't bend over from the waist and pick up a penny on the floor. That would have just toppled me over. I had to wait until my brain became used to using those inner ear balance organs again, and it took about 3 days for those to come back online. Now, for space station astronauts like my friend Bill MacArthur, who's headed back to Earth on April 8th here, he's been up there for more than 6 months, and he's been exercising every day for 90 minutes. He's been using both a treadmill and an exercise bike and a resistive exercise device that allows him to do the equivalent of lifting weights up there. And by combining those forms of exercise, his muscle and cardiac health will be in pretty good shape when he comes home. So I think he'll be able to walk within about an hour. He's got the benefit of a lot of experience since that Russian mission 16 or 17 years ago. He'll be able to be more mobile when he comes back. He will have, however, some loss of calcium from his skeleton. He's lost some bone mass. Some of that will recover back on Earth. He'll probably have a permanent deficit of a few percent. And, of course, we don't know the long-term repercussions of that. So while he's going to get some professional physical rehabilitation, I think he'll have no short-term ill effects, and it'll only be in the later decades of his life that he finds out whether he's got skeletal weakening that's of any consequence. It doesn't appear to be a long-term effect for these 6-month space station missions. But as you understand, Mars missions are an open question. Well, I'm afraid that's it for the first part of Exploration. Stay tuned now for the second half of Exploration where we go on to Mars. Is it worthwhile to put astronauts on the surface of the Red Planet? Our special guest will be Dr. Robert Zubrin, founder of the Mars Society. And the question is it worth the trip to go to Mars? What about the enormous cost of a Mars mission? What about the benefits of a Mars mission, if there are any at all? And what about the horrible dangers that astronauts face? And our special guest will be Robert Zubrin. He is the founder of the Mars Society and perhaps the single most prominent individual pushing NASA to send astronauts to the Red Planet. And now I'd like to introduce our special guest for today. We're delighted to have with us Dr. Robert Zubrin. He's an aerospace engineer and author of several books, including The Case for Mars and Mars on Earth. That's right, we're talking about President George W. Bush's Mars Initiative, and the question is, should we send humans to the planet Mars? Some people say it's too dangerous, it's too expensive, and there are other priorities. Other people say, let's go for it. So once again, our special guest today is Dr. Robert Zubrin, author of the book Case for Mars, founder of the Mars Society, and we are talking about whether or not we should put humans on the Red Planet. The first question for you, Dr. Zubrin, is how did you first get interested in science?
Well, actually, it was Sputnik. I was 5 years old at the time, and I was already reading science fiction. And while to the adult world, Sputnik was a terrifying event, or so I'm told, to me anyway, it was exhilarating because what it meant was that all these stories I was reading about the spacefaring future were going to become real. And I wanted to be part of it. And so I dug into every science book I could find. And, you know, my father got me a telescope when I was 7, and, you know, Kennedy gave his speech committing us to the moon when I was 9. And, you know, during my teen years, we were moving out. We landed on the moon when I was 17. And there was a great adventure underway, and I wanted to be part of that. I think if we were to have a Humans to Mars program today, it would encourage millions of people today to want to enter science.
And I understand you were an aerospace engineer for a while. Could you elaborate? And then how did you go about finding the Mars Society?
Well, I still am an aerospace engineer. That's what I do for a living. I used to work for Martin Marietta and then Lockheed Martin, and then I founded my own company, Pioneer Astronautics, which does technology research and development on contract for NASA and the Air Force. And that's how my source of income. That's my professional preoccupation. I don't get any money from the Mars Society. But the Mars Society was founded by me and a number of other people who, for a long time, had believed that the American space program needs a goal, and Humans to Mars should be that goal, both for scientific reasons and for inspirational reasons and for societal reasons. You know, I wrote a book called The Case for Mars in 1996. I got 4,000 letters from people who read it from all over the world, asking me all kinds of things, but basically asking, how do we make this happen? And when I showed this to the other folks in what was then called the Mars Underground, we decided the time had come to pull all this talent together and form an organization so that there would be a force in being that could actually try to make Humans to Mars happen.
Okay, well, let's talk about Mars as a planet and also Mars from science fiction. If you read all science fiction novels, they do say that Mars is a desert, but they said that this is a desert populated by Tharks and Martians and all sorts of different denizens and aliens. So first of all, tell us a little bit about the geology and atmosphere of Mars.
Okay, well, Mars is a desert today, although as we're now learning, it wasn't always so. It's a frozen desert. It's a polar desert, like what we have in the Canadian Arctic. And in fact, the Mars Society has built a Mars station in the Canadian Arctic to learn how to explore these kinds of environments. It's unlikely that there's life on the Martian surface today, but we can identify places on Mars. And of course, the news this week is that we have identified for sure places on the surface of Mars that were once warm and wet and that could have supported life. And that makes Mars really the Rosetta Stone for letting us know whether the conjecture that life originates as a natural development of complexity from chemistry wherever it has a acceptable environment, whether that is true or not. If that's true, then life is plentiful in the universe. If it's not true, if there's an element of miraculous chance involved in forming these DNAs and RNAs and all these other very complex molecules, then we could be alone. And Mars is the critical test that's going to let us find out by looking for fossils on the surface of Mars and by drilling down into the ground and reaching groundwater where there might still be extant Martian life today.
Okay, well, for those people who saw Arnold Schwarzenegger in the movie Total Recall, they know a little bit about Martian ecology. It's very cold up there, and the atmosphere is very thin.
Yes.
And so the question is, what would it take for an astronaut to live on Mars, given the fact that it's cold? The atmosphere is like 1% of the atmospheric pressure of the Earth, and there are huge sandstorms on Mars. So tell us a little bit about what it would like to live on Mars.
Okay. Well, as you point out, the atmospheric pressure on Mars is much too low to allow an unprotected human to walk around on the Martian surface today. So you would have to wear a spacesuit when you went outside. When you're inside, you could be inside of your habitat modules, which are like big tuna cans with life support systems in them, and you would live in them in a shirt-sleeve environment. It's actually, the temperature extremes on Mars are worse than the Earth, but much less bad than the Moon. Actually, on Mars, in the middle of the day, it gets to about 50 Fahrenheit. At night, it might go down to minus 130, so probably be a good idea to stay inside at night. The dust storms on Mars occur periodically, but actually, because the Martian air is so thin, these high winds up to 100 miles an hour don't have that much dynamic pressure. The 100-mile-an-hour wind on Mars has about the same force as a 10-mile-an-hour wind on Earth. So they're not really a threat, except if they're happening while you're landing, and then you have a big parachute out, which could be seized by such winds. But if you're on the ground, you could weather them quite easily, and the Viking landers weathered many dust storms without any difficulty at all.
And I understand the gravity is weaker, and the day is about similar to a day on the Earth. So tell us a little bit about what it would be like in terms of a day, the seasons, and the gravity on Mars.
Well, the gravity on Mars is 38% that of Earth. So if you weighed, 100 pounds, on Earth, you'd weigh 38 pounds on Mars. So that's an advantage. It means that if you're walking around with a big, heavy spacesuit, let's say you weighed 150 pounds and your spacesuit weighs 200 pounds on Earth, you wouldn't be able to walk around in that on Earth. But on Mars, the total mass is 350 pounds, and it would only feel like about 110 pounds. So you would actually feel lighter on Mars, even wearing that spacesuit, than you would if you were on Earth naked. So that's an advantage. The day is 24 hours, 37 minutes long. So it's really just like an Earth day. People can adapt to that quite easily. And it's all one of the things that make Mars attractive for settlement, because you could grow plants in greenhouses lit by natural sunlight, since the diurnal cycle of light and dark would be very similar to Earth. This is, for instance, not the case on the Moon, where you have 14 days of light and 14 days of dark at a time, which is unacceptable to most plants.
Okay, and also tell us a little bit about the water. You said that Mars once upon a time had flowing rivers and perhaps even an ocean, but what happened?
Well, it's not completely clear what happened, but the dominant theory is as follows. That Mars in its early history was warm and wet because it had a thick CO2 atmosphere, which made a very strong greenhouse effect on the planet. People are talking about global warming on the Earth due to CO2 emissions from industry. Well, and that can warm a planet because CO2 traps heat. On Mars, you had a much thicker CO2 atmosphere, so much so that even though the planet was farther away from the sun than the Earth, it was still warm enough for liquid water. So a greenhouse effect, bad on Earth, but it's good on Mars. Now, the problem, though, with Mars is that the planet is too small for plate tectonics. And the reason why this is an issue is the following, that when you have rain, as you did in the early Mars, and you do on Earth, of course, CO2 dissolves readily in water. It gets taken down by the rainwater into the ground, where it reacts readily with rocks to form carbonates. Now, on Earth, those carbonates are recycled back into the atmosphere through the motion of the geology, through plate tectonics that melts all rocks on timescales of around 100 million years and returns the CO2 back into the biosphere. On Mars, once the stuff gets locked up as carbonates, it's pretty much locked up. So the CO2 atmosphere on Mars started to thin out over time. Now, as it thinned out over time, Mars started to cool because the greenhouse effect got weaker. And when it reaches a certain low temperature, then soil has the capacity to sponge in CO2. Adsorption is what it's called. And once absorption begins, that thins out the atmosphere much more rapidly than carbonate formation, and you get a runaway icebox effect, where the more CO2 is absorbed, the colder it gets, the more is absorbed, and wham, the whole planet freezes up. And it's been in deep freeze now for perhaps 3 billion years.
Dr. Zubrin, some scientists have said that there's the potential of creating an artificial greenhouse effect on the red planet, which would then raise the temperatures on Mars. Could you elaborate?
Now, someday, human settlers on Mars, when there's enough of them and they have enough industrial capability, could conceivably set up factories on Mars for producing artificial greenhouse gases like fluorocarbons. You don't want to do chlorofluorocarbons because they destroy ozone, but fluorocarbons don't destroy ozone, and but they're very powerful greenhouse gases. And if you produce them and you warm the planet up around 10 degrees C through your own efforts, that would warm the planet enough that CO2 would outgas out of the soil and start adding to your greenhouse effect, and we could raise the planet by 50 degrees centigrade. We could create a Mars whose tropical regions were tropical, and in which there's liquid water on the surface again. And While you couldn't breathe that atmosphere because it'd be almost all CO2, plants could, and when you could put plants on the ground outside, there'd be rain, there'd be water cycling, and you could start to green Mars. It'd be a tremendous accomplishment of positive environmental engineering.
Okay. Well, also tell us about the ice caps of Mars. Some people think that some of the water snowed on the ice caps. Other people think that the water is still there underground in the permafrost. Could you elaborate?
Yes. Well, there is water on Mars, and almost undoubtedly in both of those locations. We can see the northern polar ice cap on Mars is water ice. And it looks like people thought the southern ice cap might have been mostly CO2 ice, but measurements that we've taken from our orbiters indicate that it's at least 60% water ice as well, and possibly all water ice. And then we can see geologic features that look like water bursting out of the sides of craters in the geologically recent period, which means there has to be subsurface aquifers of liquid water that occasionally break loose. So that's one reason why you really want to send human explorers to Mars, because if we're going to find life on Mars, actual living organisms, not just fossils, we're going to have to set up drilling rigs and reach that groundwater. Then you want to take that water into your habitat on Mars, throw it into bacterial culture medium, see if anything grows. If it does, image it in your microscopes, test it with biochemical testing, see what it's like, see if it mimics the biochemistry of Earth life or if it's something different. This is something we really want to know. We really want to know if all life as it is in the universe is the same as Earth life, since all Earth life is biochemically the same. We all use the same amino acids and the same RNA and DNA method of transmitting information, or are there other methods of creating life? So this is one of the fundamental questions in science today, and the way we're going to resolve it is by going to Mars.
Well, we don't see any liquid water on Mars today, but some people think that perhaps there could be underground geysers or underground hot springs due to volcanic activity, in which case there could be pockets of liquid water even today. But what are your thoughts?
Well, as I said, the geomorphological evidence is that there is underground liquid water on Mars today, because the Mars Global Surveyor orbiter took pictures from orbit that showed channels that have been cut out from the sides of craters from water bursting out from the sides, and these things are totally uncratered themselves, which means they happened in the past few million years, which is basically, from the geological point of view, today. So if water could burst out of the side of a crater 4 million years ago, it could do it tomorrow. And that means there has to be liquid water underground on Mars now.
Okay, now let's talk about the robotic exploration of Mars. Some scientists have called Mars the death planet because so many Mars missions have failed. However, we now have rovers on the surface of Mars looking at rock formations. What have they found specifically that has excited the imagination of scientists, the two rovers on Mars?
Okay, well, let me just point out that 12 out of 16 American spacecraft sent to Mars have succeeded. Okay, 4 out of 5 of our landers have succeeded. The reason why the Mars statistics are so low is because the Russians sent 14 spacecraft to Mars, and all of theirs failed. But in terms of our own record with regard to Mars, we're batting around 700. Now, what have we found? Okay, well, from orbit, we have found water erosion features all over the place, dry riverbeds, dry lake beds, what looks like perhaps the basin of a dried-up northern ocean. On the ground, what we just found this week is that these water features were not created by water that was just there in some flash floods that lasted an afternoon and then the water was gone, which is what some people had been suggesting. But rather, this water was there for a long period of time. We found what the Opportunity rover has found are what's called evaporites, that is, residues left when water evaporates, and the salts in the water and the sulfates in the water have been left behind. This requires standing bodies of water that exist for long periods of time and stay in place long enough for the water to evaporate away. And what's very conclusive, what we've learned from these robots, is there have been places on Mars where life could have developed. And now the key question is, did it? Okay,
now let's talk about the practical implications of sending Men to Mars, as advocated by President George W. Bush. First of all, let me play devil's advocate. Let's talk about cost. We know we could do it. We just put enough money into it, throw money at it, and we could put men on Mars. George Bush Sr., when he proposed a manned mission to Mars, numbers that were being thrown out were on the order of $500 billion. What do you think it would cost under your program to put men on Mars?
I think we could have people on Mars within 10 years for $40 to $50 billion. The issue here is actually constraining the problem in the way President Kennedy did with Apollo, where you put a timeline on it, and you say, you've got to do this within a decade. And so you don't just launch a plethora of programs and say, well, this might be useful for someday in the future when people go to the moon or to Mars, and this might be useful. Instead, you sit down, you design an end-to-end plan for how to do it, you design a coherent set of hardware elements to implement that plan, you develop those hardware elements and the associated technologies and no others, you build them, and you fly the mission. If you do that, you can be on Mars in a decade. If you don't do that, you can spend any amount of money you like, and you can spend decade after decade, and you'll have no progress at all. And this is the difference between the NASA of the Apollo period, of the basically from 61 to 73, and the NASA of the 3 decades since. It may startle people to learn that NASA's budget this year is something like 94% of what its average budget was during the Apollo period in real inflation-adjusted dollars. That is, the average Apollo period budget in today's money was $17 billion a year. NASA's budget this year is $16 billion. And we've spent as much money in NASA between 1990 and today as we did between 61 and 73. But in that earlier period, we developed all the space technologies we have and that we use, and we sent people to the moon, and we sent 40 lunar and planetary probes out. In the period between 1990 and today, we developed no new space technologies. We did not fly anyone to the moon or anywhere like that, and we flew maybe, 7 or 8 planetary probes. So when you actually have a goal and you force the organization to address that goal rather than use that goal as a rationale for doing whatever it pleases to do, except for the goal, you can really accomplish something.
Okay, now one of your plans, which is controversial, is to give our astronauts a one-way ticket to Mars, have them develop rocket fuel themselves for the return trip. So tell us a little bit about how that is done in order to reduce costs.
Okay, this is known as the Mars Direct Plan, and it's explained at length in my book, The Case for Mars. The way this works is you do this mission with 2 launches of a heavy-lift launch vehicle of equal capability to the Saturn V moon rockets that we used in the 60s. The first rocket shoots to Mars an Earth return vehicle with no one in it. Now that goes out and that lands on Mars. Then you run a pump and you suck in the Martian air, which is mostly carbon dioxide gas. You react that carbon dioxide with a small amount of hydrogen that you brought from Earth to produce a large supply of methane oxygen rocket propellant. So now you have a fully fueled Earth return vehicle sitting, waiting for you on the surface of Mars. Once that is done, then you launch the crew out to Mars with the second rocket. Okay? Now, because the return ride is waiting for them on the surface of Mars, they don't need to fly to Mars in a gigantic Battlestar Galactica spaceship that nobody knows how to build. Okay? They can just fly to Mars in a basic habitation module, like a big tuna can, flies out to Mars. It takes 6 months to get to Mars with chemical propulsion. We do not need nuclear propulsion to get to Mars in 6 months. Mars Odyssey did it in 2001. In 6 months, we can get there right now with this. We go to Mars. We land near the Earth return vehicle. We use the same habitat that we used as our ship to go to Mars to be our house on Mars for a year and a half while we explore the planet. And then, at the end of that time, we get in the Earth return vehicle and we fly back to Earth. We leave the habitat behind on Mars. So each time you do this, you add another habitat to the base. And before long, you've built up the beginning of the first human settlement on a new world. There is nothing in this that is beyond our technology, and I might add that the risk associated with this plan is much lower than that of the conventional mission, because the conventional mission involves extremely complex on-orbit assembly of mega spacecraft, which has much lower quality control than you can ever have on the ground at the Cape, integrating the much smaller spacecraft that are required for this mission. And furthermore, The return vehicle has already been landed on Mars before you leave Earth, and that's actually safer than the conventional mission in which you attempt to land on Mars in the vehicle that you hope to take off from. In other words, here you know before you've even left Earth that you already have an ascent vehicle that has survived the trauma of landing on Mars. In the other mission plan, you don't. So this plan is doable with our technology. It's much less costly than the standard plan. It's much less risky than the standard plan. It accomplishes a lot more science than the standard plan because all the crew is on Mars. No one is left in orbit. And we've got the technology to do it. So all it takes is some vision, some guts, and a little bit of moxie.
Okay, well, I was watching CNN television the other day, and the commentator said, well, the Mars rover is going on Mars, but what did it find? Rocks. Rocks, rocks, and more rocks. And what he was implying, therefore, is that there's really not a pot of gold out there. There's really no reason to spend any more money on the mission to Mars. So let me ask you a question. What are the economic benefits? Why go to Mars if it's an enormous amount of money for a goal that is a little bit dubious?
Well, the goal is not dubious at all. And saying there's nothing on Mars but rocks is like saying in 1600 there's nothing in North America but trees and animals. I mean, it's an extremely anti-intellectual and stupid statement. What there is on Mars is a world. It is a planet with a surface area equal to all the continents of the Earth put together. And it has on it all the resources needed to support life and therefore potentially human civilization. And if we can go to Mars and develop the technologies that allow human beings to be self-sufficient in this environment, as previous generations of our ancestors, starting from those who left Africa to take on Ice Age Europe, did. Human beings have used their creativity to master environments that were previously considered uninhabitable. If we can do this, then we can create the conditions whereby new branches of human civilization can develop on Mars. 500 years from now, if we do this, and people look back on our time, okay, they will consider this the most important thing we have done. No one 500 years from now will remember who was in power in Iraq or Bosnia. Okay, probably no one will have even heard of those countries. But what we did to make the transformation of humanity into a spacefaring species, a multi-planet species with basically the infinite resources of the cosmos open to it, that will be remembered and that will be celebrated.
Well, that concludes our interview with Dr. Robert Zubrin, former aerospace engineer, founder of the Mars Society, and perhaps the country's leading proponent to put men on the red planet. Now, I should also point out that in my personal point of view, I think that robots, especially for the short term, are much more efficient. They don't cost much. They don't have to come back. They don't complain. And they have given us an ocean of data about the universe. The manned space program, to be fair, has not given us that much scientific data, except perhaps for moon rocks from the lunar mission to the moon. However, in the main, robots have given us the vast majority of information concerning the cosmos. That said, however, I also believe in the words of the late Carl Sagan. Carl Sagan once said that we should be a two-planet species. In other words, at some point, we're going to have to leave the Earth. The Earth is too dangerous. On a scale of 5 billion years, the sun itself will eat up the Earth. On a scale of perhaps 50 million years, we could have another comet or meteor that could destroy all life on the planet. And on a scale of just 10,000 years, we could have another ice age. So in other words, it's good to have an insurance policy, but what's the rush? I think in the future, the cost of space travel will go down dramatically. And at that point, the manned exploration of outer space won't break the bank. Now, let me explain. To put a pound of anything into orbit around the Earth, just orbiting around the Earth, costs about $10,000. That's your weight in gold. So think of your body made out of solid gold. That's what it costs to put you in orbit around the Earth. To put you on the moon costs about 10 times that, or about $100,000 a pound to put you on the moon. But to put you on Mars would cost perhaps $1 million per pound. So think of your body weight made out of solid diamonds. Every piece of your body made out of diamonds, and then you begin to understand the sheer cost of putting men on the red planet. However, in the coming decades and maybe in the coming centuries, the cost of space travel will dramatically drop because of new propulsion systems, perhaps a space elevator, and at that point, the cosmos will really open up to human exploration. Now, some people say free enterprise and capitalism in the form of space tourism will drive humans into outer space very cheaply. However, on Exploration, we've interviewed quite a few proponents of space tourism, and they admit that the cost of going into outer space will always be expensive because of the cost of rocket fuel and the infrastructure necessary to put passengers into outer space. Perhaps space tourism may reduce the cost to a factor of 10. So it would only cost about $1,000 a pound to put you into orbit. So going into outer space would not be for the average middle-class person. It would cost as much as a house for the average person to go into outer space. So we still have to wait for new technologies to drive down the cost of space travel even farther so that the average person can then begin to access outer space, and not just millionaires going to the International Space Station at $20 million a pop.